Thanks for coming. My name is Mark O'Toole. I'm actually co-founder of AI and Data Science Meetup. We have 4 speakers, obviously, today. First up is Dat Tran, Head of Data Science at Idealo. Thanks for coming.
Okay. Okay, that's my presentation. Hello, can you hear me? Okay, so I just speak. So I just hold it in and then. Okay, okay, great. Yeah, thanks for coming. Even though it's really late, I hope it won't be boring to you guys. So today I would like to share some of my stories with, I would say, AI or machine learning, aka data science transformation. I would say at a lot of companies that I advised in the past, and also sharing my personal experience now with building up my own team at Idealo. Yeah, first of all, to introduce myself, so I'm currently co-heading the data team at Idealo with a special focus on building up the data science and data engineering team. And before that, I was working for Pivotal Labs and Accenture. Also like consulting very big companies on building software, data-driven applications. And yeah, in my heart, I'm a data scientist. I like big data, of course, but today, of course, it won't be technical, so it's more like a business-driven talk, but this is also very important because nowadays, everything that we do is kind of a product, right? And even though data science is a very mathematical and computer science, I would say, dominated domain, it still gets some business value if it's used in a product. So yeah, let me start with a story. I don't know, maybe some of you guys could relate to it. So usually, you know, every year you start maybe talking to your manager, right? And then you ask them, okay, what is the focus of this year, right? And then he's like, yeah, blockchain. This is a new bad thing. And then it will change everything, right? Everyone is talking about it. And then the potential is endless. Sometimes, you know, they just read some article on, I don't know, any newspaper, right, or any blog articles, and then they realize, oh shit, this is a technology that I need. And one of the technology that they need nowadays is AI, right? Because since AlphaGo, everyone talks about this. And the problem, though, is, especially here in Germany, you know, you have many companies who actually don't really understand what this is, right? So they always think, yeah, we have a lot of data, we have a lot of, you know, things that we can use. This, you know, data is new oil, right? So you think, hey, yeah, so why can't we have it? So why can't we be Google? Why can't we be Amazon? Why can't we be Facebook, right? So this is what a lot of German companies think. And then what they do is, you know, the story goes on. So what they do is they hire a lot of consultancies because, you know, we don't really understand what data science is, right? It's been in the field for us maybe in the last 4 or 5 years. And they build, you know, this, if I think this as an analogy, they build beautiful digital labs. You know, this is kind of also of a very beautiful location that we have here, right? You put a lot of people in there. You might put ping pong table, right? You have Club Mate, you know, you have everything shiny stuff. But the problem is the story usually ends like this because they pour in a lot of money, right? And then time goes by, products won't get released. So I've been working with Pivotal and Accenture, and you know, the clients that I've been advising, you know, they've been working for 2 years and they haven't released any products, you know, within 2 years. And then you think, okay, what they've been doing wrong, right, in this sense. And the moral of the story is that a lot of data initiatives fail because, you know, you put the wrong people on top who make wrong decisions. And as I already said, they spend a lot of money, right? So they spend a lot of money on buying tools. So tool is like, okay, let's buy Hadoop, let's buy Spark, right? So let's buy in. It will be good, right? It will be great, get some values. And then also they hire a lot of expensive consultancies, right? And then at the end of the day, they still won't get anything. But the most important, I would say, point that I've experienced so far in my career is actually they're not really able to create a sustainable and like risk culture, and I would say also agile culture in a way, right? And agility or agile lean startup, however you call it, is really difficult in a way, right? How do you do it? And this is actually the focus of my talk. I want to share some of my experience from different angles, what I think as agile, and especially with a focus on data science machine learning. So the first thing that I want to focus on is MVP. Who of you know MVP? I think all of you, right? Yeah, most of you guys know MVP. So yeah, there's this guy, Eric Ries. I think some of you might know him. He wrote this book, Lean Startup. He is a pivot. I'm an ex-pivot. And what he said is, yeah, it's a minimum viable product. It's a version of a new product which allows a team to collect the maximum amount of valid learning about customers within the least effort. And what does it mean for dummies like me, you know? So let's say we're in a situation, you're quite new in Berlin, and you just need to roof over my head and over your head. And the question is, what is the minimum solution to solve your problem? This is actually a very interesting problem because I just hired someone from the US, and he's actually facing this problem, right? So where would he start? Probably, you know, you want like hire an architecture, right? And then redesign your stuff for years, right? And then build your dream house somewhere, right? That takes years. If you think about this analogy, it's the same thing for big companies, right? They've been building, you know, these digital labs out there, this ecosystem, spending a lot of money, right? Because they think it's kind of good. But for me, you know, what I recommended is, hey, if you don't find a hostel or something, why don't you just take a tent, you know? It would be good because it solves your problem. You have something where you can live on. And then, you know, when in 2 or 3 months, you could think to have a container, right? This is also solving your problem in some way. And then finally, maybe in a couple of years, when you earn enough money, then you can offer your villa. Yeah, basically, what it is saying is that you should start with a simple, I would say, simple solution to solve your problem until you get where you are, because this is where you can get the most learning. And the question is, why is it really important? Does anyone know this company? Okay, what is this company doing? Yeah. Yeah, right. Yeah, so this company, I would say was a great company. It was a great company. It's not a company anymore. The founder was on the same level as Steve Jobs and Mark Zuckerberg and Elon Musk. This is how he described himself. As I said, is a juice squeezing machine. They actually raised $120 million in the past, and you know it took them, I would say, 1.5 years or 2 years, almost 2 years to release this product. They sold a juice squeezing machine, and along that, they also sold a couple of like these juice bags. You know, the funny thing is very pricey. So I think it was like $700 in the start. Then they somehow reduced it. But the most critical point is, you know, when you buy this machine, they didn't think about that. You know, people just use their bare hands basically to squeeze out the machine, the juice. So you didn't really need the machine, right? Basically to squeeze it out. So that's why they are dead. So that's why MVP is important, because one thing they could have done is, you know, just ask the customer, right, or people, what are they? Why were they doing this? And if would they need a machine basically to do this kind of thing? And what is the value added for this kind of product? So yeah, I mean, you know, this is a machine learning meetup, right? It's about data science, about AI. I've been talking a lot about product a lot so far. So I would like to go now to the nerdy stuff. The question, you know, so far is, we think about MVP, right? And if we think about machine learning and data science itself, if you think about all the good products nowadays that you have, for example, if you use Google Maps or Facebook or whatever, there's a lot of intelligence involved in that, right? And at the end of the day, it's a product, right? It's a product that is end somewhere. You just don't see it. If you read one of the last articles from Google in their technical depth paper, you can see that the data science of the machine learning part is only one piece of entire product, of entire infrastructure, right? And I, for myself, see machine learning ending up as a data product as well. And if we think about machine learning as a product, we can also relate MVP ideas, what we've been using so far in product management, also for data and science and machine learning products. And in this area, I've actually considering three points. So one is the minimum viable model, the second one is the platform, and the data product. So this is basically my take on MVP for data science. So if you think, let's say, think of a problem in a classification, right? A lot of problems that I've seen so far, is like, hey, let's play with deep neural networks, right? Because they're cool, right? So let's start with them already for any problem that you solve. And then maybe, in deep learning, you do a lot of hyperparameter optimization, right? Let's add another hidden layer, and then you continue to add another hidden layer, right? Actually, you could go on and on and on forever with this, but this is not the sense, because in a business world, right, we need to bring some values to the customers. So it doesn't make sense to play around and do R&D. Otherwise, you would go to university or stay at university, right? So for a simple problem, for like, let's say most of the problems that I've seen so far, you start with linear models, right? Linear models that basically show you, hey, what is the feature that's driving those things? And it's very simple for people to understand, first of all. And you can get a lot of ideas why things are not working and why things are not working. And then, of course, you would continue to more, I would say, sophisticated model, like creating trees, like tree models, right? Whether it's random forest, whether it's XGBoost, I don't care. And then, at the end of the day, you might, okay, I understand the model, I understand the business problem. Let's use deep neural networks. Of course, this is an abstraction of problems that you solve. There are a lot of specific problems that you cannot solve this way, right? For example, if you look at computer vision or natural language processing, right? There is no linear model that would solve a good computer vision task, right? So you would go straightly to deep neural networks, but this is a different story, and this is a more customized and more specific problem. In terms of platform, what I've seen so far at a lot of companies, that when they start with their digital transformation or data transformation, if they call it, what they do is they pour in a lot of money on just buying, Hadoop, Spark, or whatever. They look at the big vendors, Cloudera, Hortonworks, MapR, and then what they do is they continue with doing this. They might do a lot of ETL processes and getting things right, and then now TensorFlow and Kubernetes, right? Very cool projects. They need it as well, right? They invest into it, but without any understanding of why they're doing this, right? This is actually really bad, because when they invest a lot of money and they set a lot of big expectation because they thought that they're buying tools that they will solve the problem. But this isn't the case, because at the end of the day is the use case of the product that is driving your business in a way, and your expectation, what you can set. And what you should do, or what I would recommend, or what people to do is, if you don't know what size of your cluster that you need, or what size of what you want to do, is you start with the cloud. We have a lot of cloud servers at the moment, right? Why don't we use things that we have? If you think about good companies like Netflix, Google, they're all using this, especially in German companies. I don't get it. Why shouldn't you use it? And then, of course, in the future, you might think go on-premise in a way, because of course, cloud servers have their disadvantages. They are very expensive, right? But this is in the way that you think, do you need to hire someone, right, to take care of your operations, or do you just buy in a tool like Amazon, right, where you can have the services already available? And yeah, this is an example that I've been working on with, actually not me, I've just been handling this at Idealo. We're a price comparison site, and we have this tool which is called Preiswecker. So you as a customer can set the prices, and the Preiswecker, or the price alert, how it's called in English, got triggered if the price is basically reaching the point that you have it. One of the problems that we face is that a lot of prices are really not correct, like from our side to the e-commerce, right? So the merchant basically sometimes give maybe wrong prices, or the prices are updated because they have dynamic pricing. And of course, what we don't want to do is we want to send out a price alert, right, to the user, and then the prices already went down. So we want to check it. In the past, what we did is we checked every price alert with a lot of people. This is not, like you can hire a lot of monkeys doing this, but in the future, of course, we don't want to do this, right? So what we're doing is we're using machine learning to solve this problem because we have a lot of labor data in this way. And this platform here is something that we built within 6 weeks. And this is something that we probably get in production soon, soon as possible. Yeah, another dimension of what I've been is of course the product itself, right? I've just taken an example of the chatbot because we're thinking of doing a chatbot as well. If you think of a bad example here in this way, you could start with your recurrent network, whatever you're doing there, right? And then you just take some data, right? And then you get some data, from Twitter, and for example, like Microsoft, right? This is what basically Microsoft did. So this is a model that you can create because you didn't think about this, what could go wrong in a way, right? Or what actually are people asking on this kind of way? And there's only a few companies that are really doing chatbots correctly. A good approach would be, who knows what this is? It's a wizard. Someone heard of Wizard of Oz? Yeah. Yeah, not the guy from Wizard of Oz, but the tool to use how to do it in product management. Sabina, you know it? Yeah, so Wizard of Oz is basically a tool in product management. Basically, you're just creating an interface. It can be, I don't know, like a wireframe, right? And then you setting not a wireframe. It will say something that is live, but then you're just setting a human next to this, right? And then you have people really asking this, and then you have a human basically answering this kind of question. And then this is how you would start, because you collect things. What are people actually asking, right? And does it make sense basically for me to build a machine learning model on top of that solves the problem? Because if the questions are so trivial or doesn't make any sense, or they're so racism, so why should you build a chatbot on top of that, right? So there's something to see basically what could go wrong in a way and whether you're building the right product. So another dimension that I want to talk about is culture. And the first thing is, who actually knows what this is? Yeah? Yeah, it's a cargo cult. So this is actually, like an airplane and like built in the wood. These are some native people somewhere in the Pacific. It was during the World War. Does everyone know what cargo cult means? Yeah. So cargo cult is, I would say, is a good analogy for me for digital labs, right? Because when you start with thinking about like cargo cult in some way, like in the past during the Second World War, you had these people, basically building up fake airplanes. You have people really waving, on the one way because they think that a god would come, and then give us some cargo and supplies, so that it would be good. And I see this analogy basically similar to digital lab nowadays, because there's a lot of companies, they take in like this building here, they build a lot of cool things, right? They hire cool people, young people, and then of course they have all these shiny MacBooks and all this stuff, right? Because they think that US American companies who are very successful in doing this are just doing this and then they are successful. But this was not the case, because if you think about San Francisco, has anyone been to San Francisco before? Yeah. And do you all know that this is so expensive to live in San Francisco, just to stay there? So the real reason why those companies have to move into this kind of industry complex and whatever is not because they wanted to, because they had to, because it was about the price, It was the price that because they had to move in. And then all what we do is we look at these companies and they would think, they're all moving in this industry complex. We should always also doing something like this, and then we'll be successful. But for me, the real success is not that you have all this shiny stuff, but is actually the culture that you create within a company, right? And for me, it's an engineering culture, because at the end of the day, we're a tech company. Idealo is a tech company, and a lot of companies as well also in Germany, are turning into tech companies. And for this, we need a good tech culture, basically, to create good products, which are sustainable and also have a sustainable culture. And one thing that I've pointed out is like a good engineering culture, right? Things like pair programming, continuous integration, also test-driven development is very important. Then another one that I've already talked about is like the hypothesis-driven approach, right? So if you are a company and not thinking about creating customer-focused centric products, I would tell you that you will die soon. And then, of course, what is also important is that you need to think machine learning as a product and also as a core of a lot of what we do nowadays. If we think about Google and Facebook, or I don't know if you read about Google in the last week, you know that the AI team, so the Google Brain team, is basically sitting next to the CEO. The similar thing goes to Facebook. The entire AI team is sitting next to the top management. So this is so important for those companies. And yeah, I don't think that we've been going this so far and think about this, especially here in Germany. And yeah, another dimension that I would also, and there's also the final dimension that is also important. You all know these guys, they're cool guys, you know. They do not work for Julio. Maybe some of them only for a short time. But it's very important to hire the right people, of course. I mean, what we know is, you know, at big companies or some companies, you know, they hire a lot of old, I wouldn't say old people, but people who've been in the company for years, right? And then they got promoted, and then they become digital leaders or I don't know, whatever they do. But they're just not the right people. They shouldn't be there because they don't understand what people want nowadays and what it means, right? So it's very important as well. And I brought along a job requirement from one of a big company. It's you know, everyone knows Deutsche Telekom, right? So it's the biggest provider here in Germany. And I pointed out some stuff whether you would apply for a data science position, because you know, if you think about this, right? If you were a data scientist, so do you have 10 years of experience, you know, in IoT? Is it necessary? I don't think so. And also, what the fuck has JavaScript to do with this job that we do, right? And also, yeah, Gestaltung, Verwaltung von Big Data, you know, ops operations. So why would you care about ops, you know? So you have people who can do it, and or you use Amazon, or you train onto it, right? And then configuration of components. Are we, you know, working in infrastructure? I don't think so. And also, yeah, please have experience with at least 2 of this stuff, you know. So, hey, I don't know where to find this guy, you know. But if they find this guy, I'm happy for them. And the most important thing, you have to learn German. So why do we have to learn German? You know, this is such a difficult language. I mean, I'm a German native. I can say this is a difficult language, and especially here in this case, right? So why do you have to read such a job description which doesn't make sense, you know, for this position? And why didn't they ask someone who had an understanding of what a data scientist and machine learner is, right, before they really post these things? And then, yeah, this is kind of a thing. Okay. But yeah, this is an example. And I found it 3 weeks ago. So, no worries. But of course, this is only an example. There's a lot of other companies that you can see on Glassdoor and other companies who are really like showing the same thing with this job description. Yeah, so I would like to conclude my talk. So actually what I've said, there's no right or wrong. I just shared my personal experience, right? So some of this might be BS. Some of them might be valuable to you. I hope so. For me, data science, machine learning is only one part of a product, right? And it has to be included into an entire, I would say, culture or I would chain of things. And one important thing is to establish such a good culture in a company to be successful. And yeah, as I said, hiring is difficult, but I think some companies need to change. I would say faster than enough, not in 1 or 2 years, especially if you want to keep up with, I would say, US companies, right? Or digital companies who are successful. Yeah, thanks for your attention. And one last comment, we are hiring data scientists and data engineers. So if you want to speak to me later, I'm here.
Thanks, Dat. Next up, Noa Tamir from Data Science Lead at Babbel. Good luck.
Thank you. Hi, everyone. So, let's see. Yeah, so hi, my name is Noa. I work at Babbel. And a nice lead up maybe to my topic, so it's kind of adjacent to what you were talking about. So I would like to talk about how do you actually get to have data culture in an organization in practice and give you some examples of how to achieve that. Why would you maybe even want to or care to do this? I mean, I think probably in most of the organizations you work in, not everybody is fluent in statistics and programming, just as much as not everybody knows how to design and not everybody knows how to write a good contract. So it's obvious that when we talk about and try to drive data products, data science analysis, and decision making that is based and driven by data, we can't assume that everybody knows and understands it to the level that maybe your data science team or analytics department knows it. So how do we actually do that? How do we actually get everybody aligned, using things in the right way, choosing to use recommendations and tools, if you don't teach everybody statistics and programming, right? So I would like to talk a little bit about, give you some examples from how I do it, and I'll start maybe with, again, what maybe are my fundamentals of what a data culture is, so how do you know maybe that you've achieved this? So like all good things, I have 3 examples. So I think first thing is about building trust, so making sure that people, again, trust you when you propose timelines, trust you when you say you can do something, trust to use the results of what you produce, and to take your advice. So I think that is something that a reason to why you want to have not just a really good data science team, but a really good data-driven culture in your company. Another thing is access to data. So if you're limiting data access to only the teams that absolutely have to do it in order to be able to do their work, you might not be able to achieve the data culture in the same way. So enabling access, making sure that people can touch the data, see the data, and interact with it, code-free, hopefully, then that would actually help and help drive your culture and make you also seem accessible and your team seem accessible and the ideas that you're working on as well. And then knowledge, of course, so great. They trust you can do things, they know they can access the data, but then of course what to do with it and how to know that you know what to do with it. So maybe those are the 3 things that I think are worthwhile to consider trying to build up a data-driven culture in your organizations as well, if they don't have it already. I hope you do. So before we start, I'm going to start with this. So much like anything else, I think in science, does everybody know who said this? Newton, right? Though you can also find it in Google Scholar, and you can also know that Hawkins quoted it and is often misquoted as the first person to say this. So much like many things, while data science is rather new and maybe not everybody has 10+ years of experience in data science and IoT, that's very valid. Scientific culture and the culture of exploration, the culture of achieving new horizons is not new. And we can definitely reuse ideas and themes from that history and culture in order to connect people to what we're doing right now. So I'm going to show you a bunch of examples from all sorts of workshops, trainings, talks, and activities that I run at Babbel, and I hope it'll inspire you to try maybe to do a few of these sessions yourselves. And the way I do it, so always there's going to be no equations. And I'm going to, instead of equations, use stories. And I hope that this will be interesting and relevant to what you do as well. So what kind of stories or themes are we going to be talking about? I think it's going to be very obvious how all of this is connected to data science in a moment. We're going to talk about climate change, parole decisions, mozzarella, and James Lind, who is one of my personal heroes. Does anyone know who he is? So I hope by the end of this talk he will be your hero as well. So let's get started with climate change. So this is Mawson, Douglas Mawson, and he led the Antarctic expedition in 1929 to 1931. It's a scientific expedition for exploration in the times where we didn't know a lot about Antarctica or the poles in general. They made amazing discoveries and really advanced science for that time. But beyond that, they also kept meticulous records of everything, including water levels, water temperatures, things that weren't necessarily related to the discoveries that they were trying to do. And right now, thanks to them, we are digitizing all these data sets. I think the project is almost done. And this data is currently being used to study climate change, and that's how we have water temperature and levels in Antarctica from those decades. You don't always know what your data will be useful for and used for right now and in the future, but you should, I think, always care about data quality, just like Mawson's expedition cared about it. And this story is a part of a workshop that I run about tracking, design, and testing. It's about the life cycle of how do we get tracking set up correctly in a company. As data scientists, we are a major stakeholder in this, and we bring in all the relevant stakeholders. So we bring in QA, we're bringing programmers, we're bringing product managers, and we really align everything, processes and input, in order to be able to make sure that at the end we have really good data quality at our hands. So, up to the next topic, which is parole decisions. And if any of you are into product analytics, which I am really into, and data science, then you must be also very much excited about behavioral science and know all the research. And I want to show you an example of a very important paper, and I think a very interesting one. It's called Extraneous Factors in Judicial Decisions. And I know that's really exciting, really great topic, but it does have fascinating insights for behavioral data science. For example, this is one of their main findings. I think it's really clear what they're going for, right? Does anyone know what the circles are? Yeah? Yeah, that's true. So you're more likely to be released from prison if your parole hearing is just after your judge had some food. It's kind of an incredible finding. I'm not sure that if you read the paper, that you look at this graph, you're like, this is what this is all about. Of course, there is a great amount of text underneath describing what the graph is, but then what's the point of putting the graph if you need to read the paper? What could we do to improve this, maybe? Any ideas? So simply add annotations. I did this. It's not in the original paper. I think if you add these, the graph speaks for itself, and your finding speaks for itself, and you point people very quickly in the right direction, and they don't need to read pages and pages of slow-moving text. I think that you can and should always communicate as much, and communication is a very important part of data science and effective data science culture. So this parole decision story is actually from data visualization workshop, where we talk about visual communication fundamentals and really link them to data visualization in practice. So how does the fundamental of understanding visual communication, what people can grasp and what you can show, actually relates to how we illustrate things and data graphically. So you could improve your reports, you could improve diagrams, presentations to all across levels of the organizations. So I think it's as important as a public speaking or presentation workshop, which most companies that offer workshops offer, but might be slightly biased on this one, because most companies don't offer this one. All right, example number 3. Mozzarella, again, obvious how it's related to data science. Great cheese. It's also happened to be that since the year 2000, Americans have consumed more and more of this mozzarella cheese. They like it very much. So consumption has gone up from 3.5 kilo per person to about 5 kilo per person. Related to that, this is the MIT campus. It's one of the top schools for civil engineering. And similarly, since 2000, this has been one of the schools that's been contributing a nice, consistent rise in doctorates in civil engineering. It's one of the schools that actually gives doctorates in this topic. So it's pretty obvious, right, what I'm going for. So this is the correlation between PhDs in civil engineering and consumption of mozzarella cheese in the United States. I don't know if you or people in your organization often look at correlations. I'm not sure if we should use this for prediction. So my point is that spurious correlations are great source materials for jokes, but not necessarily great data tools, and they are very, very commonly misused and also very commonly used. And similarly to that, there's a nice tool in Google where you can check correlations. I thought maybe we could make a recommendation of how we should plan the marketing strategy for meetups. Obviously, we should definitely look at indicators like people searching for how to make a baby. Not a baby, just baby. So again, I think while spurious correlations and time series analysis can be a rather complex or advanced topic, I do think there are easy ways to illustrate your point and to make sure that people, don't just say, but this moves like that. So, and really it's one of the things that are really biasing people, even with degrees in statistics. And just because everybody loves XKCD, I think you should always use XKCD in your slides. So this tasty example is from a talk that I give about common pitfalls in applied statistics and analytics. Also dubbed, it's never a bad idea to talk to a data scientist. So even when you think you know what you're doing, or things that are very commonly used can mislead us slightly. So on to the next topic, my hero, James Lind, as promised. So in 1747, a young Scottish naval surgeon boards the HMS Salisbury and is about to change history for absolutely everyone. Does anyone know what scurvy is? Yeah, so this is a really unpleasant disease and thankfully isn't very common anymore. It's actually a vitamin deficiency. It was extremely common in sailors at that time. About 2 million sailors died from this disease, and going back for that time, it was a very significant amount. It's not surprising, anyone could have got it at the time. Vitamins weren't discovered yet, no one knew what it was, so you can just go and make sure that you have enough. But sailors were often long time at seas, and they had biscuits, dried meat, some fish, and they didn't pack fruit with them, and also if they would have, it would have gone bad after a few days. So since vitamins haven't been discovered yet, scurvy is a very serious disease, and James Lind decided to do something that no one has ever done before. He's disregarding fashion, hearsay, criticism on his decision, and he decides to check what would be a good cure for scurvy, unlike using common treatments that were available at the time, but weren't inconclusive which one is true. For example, you could cure this with acid, with salt water, with burying someone in the sand up to the neck, or also with hard labor, which is a case of mixing cause and effect, because they thought sailors who had this were lazy. So actually they were sick, so they couldn't work so well, and they kind of misunderstood it, so they actually made them work harder, which is a bit of a shame. So instead, as he is on the HMS Salisbury, he decides to run an experiment. He takes 12 people who suffer from scurvy, similar condition. He puts them in the same part of the ship. He gives them the same food and the same water, same level of treatment and attention. And while you can see that the groups are very small, it's a tiny experiment. Luckily for him, the finding is so significant that even he could recognize it. So actually, oranges and lemons were added as a treatment, as a shot in the dark, somehow of a, if we do nothing, what happens? Because he had some around, it was still near to when they left. They actually ran out of them after 5 days, but by then the 2 people who got it already were healed while the other people were still sick. And the 2 people who got cider had mild improvements by the end of the experiment. It's probably because there's some fruit in cider. So it is a pretty significant finding. And he just invented the controlled clinical trial, or as what many people in your organization know, an A/B test. So no one has done this before. And of course, if he was living these days, I'm sure he would have been published well, and good findings and so on. But he didn't really do that. He took 6 years to write a book that's about 600 pages. It's very slow-moving text again. It's called A Treatise on Scurvy, so no one would have gone and find this is how you know if medicine is effective. And it didn't win many supporters. It was lost and forgotten, and actually someone had to reinvent this later on. So I think it's quite important, and we found his notes were found in a house in Scotland, and basically that's how we know he actually did this. His work was really ignored and lost. So this story of James Lind is from a talk about A/B testing and how you could explain A/B testing without any statistics to people in your organization, and make sure that they understand why you should testing and not just release something and just check before and after what's the problem. I think that might be all we have time for today, though if you want to catch me later to hear more examples of ideas. Quick roundup, we talked a little bit about tracking. We talk about data visualization, about common pitfalls in analytics, an introduction to A/B testing. Those were expeditions to Antarctica, parole decisions, mozzarella cheese, and James Lind. I hope I gave you a few examples so you can go beyond this and go back to your teams and decide what to do. And just maybe my final note about data culture is that it doesn't have to be exclusive, it doesn't have to be intimidating, it doesn't have to be all about mathematics and programming. It could actually be fun, and I encourage you all to seek out stories and to tell stories in your teams and in your companies that you work in, and in general. And that's it.
Thanks again, Noa. Next up is Colin Clark. Colin Clark is managing everything data at CoinBau GmbH. Colin Clark is actually new to Germany. He's only been here a few months. His background actually was principal data engineer for the 3rd largest e-commerce business in the whole of America. Is that right? There or thereabouts. So yeah, welcome, Colin.
Hello. Where's Dat? I am the old guy. The first rules-based system or predictive analytics system that I put together was in 1987. So I've been doing this for a while, and I thought I would share with you some of the things that I've learned about data science, and specifically some of the issues that I see in Germany, which I think some other people have been touching on as well. So my frame of reference for this discussion, and it is a discussion, I'm not good at PowerPoints, so stop and ask me a question at any time, but is if let's all pretend that we work for Wayfair or across the river at Zalando or eBay or Amazon or Digital River, right, some big e-commerce provider, right? And so what we're going to talk about tonight is what I've seen and why these projects fail, right? Because we've seen this before. We saw this with AI in the 70s. We saw this with BI in the 80s, right? People just sprinkle a little technology salt on something and then they expect to get instant ROI and they wonder why things fail, right? And they typically fail for some of the reasons that I've listed here. We're just going to dive in. But before we do, when you sell stuff online, there's an analog, right? And GDPR in the EU is kind of bringing people back to this. When I grew up, my father went to a tailor, and that tailor got to know our family. And when that tailor found a fabric that my dad might like a suit in, he would call my father, right? Well, that's kind of happening today with recommendation engines, right? And so back then, the corner store, right, what am I selling, right? What kind of store am I, right? Am I a high-end clothing store? Am I a Walmart, right? What is my target market? How do we sell stuff, right? Is it appointment only? Is it fitting? Do I have an online presence? Do I have mail catalogs, right? How am I reaching my customer? How do they buy the stuff they sell? Where do they source it? What is their supply chain, right? And how do they manage their staff, right? How do they actually manage their operations? Nothing has really changed, except we're doing it. We've replaced that salesperson with recommendation engines, with personalization. We've applied machine learning to our supply chain, right, to internal operations, to our HR in terms of who we hire, how we promote, et cetera. And all we're really doing is replacing that guy that we used to go to 30 years ago behind the counter, right? We're just trying to do it at scale. So let's start with something that's on everybody's favorite list, right? Raise your hand if the risk group or the compliance group is your friend in data science, okay? So this is where it all starts, and I'm going to give some examples, right? So complying with contracts, one company that I went to work for, who will remain unnamed, right, will protect the guilty, they were selling database products with customer data that they had gleaned via online sales that went against the contracts that they had with those customers, right? And if somebody would have found that out, and it would have been very easy to prove, right? Any data scientist in this room could have looked at some of the numbers and what we were presenting and comparing them to and say, hey, wait a minute, something's odd here, right? That's my data that you're showing, right? So make sure that you can do what you want to do with data science contractually, right? Keeping the regulators happy. Everybody knows about GDPR, okay? Well, that's relatively new in the EU, right? Coming to effect in May, but in the States we've been dealing with this for quite some time. I set the Wayback Machine 10 years ago with AOL. When we did a proof of concept, right, we had to have attorneys in the room when we talked anything about our customer data to make sure that what we were doing with that customer data was legal, right? And that if somebody found out about it and published it, that we weren't going to take a black eye in the press, okay? And one big question that people kind of gloss over in data governance is, who are we? What kind of company do we want to be? And there are two examples that I can give that are really, really serious about what happens when you don't get this right, okay? And you may have heard the story. One example, a woman was buying things off the web that were somewhat embarrassing, right? And an ex-flame of hers decided to expose that, and because the company was encrypting the data instead of anonymizing it, the person who was trying to expose the behavior was able to link the transactions and then post publicly what the woman had been buying. She committed suicide. Okay, so anonymization of data versus encryption of data, that's serious, right? It's really serious. Another large company in the United States did kind of the same thing, and we can get a little creepy with our data science. We can predict where you're going to be, excuse me, what restaurant you're eating at, what route you're taking to work, right? Well, this company sent some coupons to a family because they knew that there was a woman who was pregnant, right, in the home. Well, she was underage, and her dad got the coupons, right? That turned into a huge issue for this company in the United States. And so this question about who are we, right, that's important, right? it determines what you're going to do with your data science, right? Are you going to be creepy? Are you going to be helpful, right? How far are you going to go? And I touched on this briefly before. The new big and nasty is GDPR. You know, and this is one of the things I want to talk about too, is for people who are looking for a career in data science. GDPR is going to create about 20,000 jobs in the EU, and about 50% of the companies in the EU aren't ready for it yet, right? And so if you're interested in helping data governance become an enabler for data science, this is a great place to start, because they're going to have to pull you into every project that they work on if they want to be compliant. So after you decide what kind of company you want to be, and you decide, well, I want the freshest data, I want the most accurate data, I want the highest quality data, right? We get into data management. And so master data management, again, large retail company, what's my customer database? What's my product database? What's my promotion database? What's my store database? Right? Because it's an intersection of all those things. And you want those things to be accurate, right? That's really important. And I don't like the term data science. I don't like the term AI. I prefer automated decisioning, right? And the reason for that is that it can be heuristics, it can be rules, it can be predictive, it can be machine learning, or AI. I don't even really know what AI means, right, in that scheme. But I preferred automated decisioning. And it's important that we get these things right. I think Dat was talking about pricing, right? So how many people have ever gone to Amazon and seen a book for 900 bucks, right? That's a problem, right? Or at Target, we would price all of our stuff in the stores online, you know, several thousand times a minute, and sometimes we get bad data and the price would go through the roof and then we wouldn't sell anything, right? So that's serious. Metadata. In a large company, are any BI people in the audience? There's got to be some somewhere. All right. How much time do you spend a day looking for data to answer questions? Oh, yeah, okay. So without good metadata, right, where is my data? Right? What format is my data in? Right? And you can take that to the nth degree. You push a button and you generate on-the-wire formats for your data. You can enforce quality, right, so that your machine learning algorithms have better data when you get to that level. Entity resolution. It's been proven in the United States that you go to work for one Walmart, you get arrested for fraud, right? You go to jail. Well, they weren't sharing their employee databases between stores, right? So they were employing the same criminals over and over again, right? So entity resolution is really important, right? The same thing can't be in two places at the same time. Data engineering, 80% of being a data scientist is being a data plumber. And this is, as we get into this is one of the jobs that's harder to automate. In my last job in retail in the US, we had, you know, over 1,500 stores. We had hundreds of thousands of products. Our stores were personalized. We sold different products at different locations in the stores. And the data science, that was the easy part. Right? Getting everything staged and the pipelines built and presented and quality data in time to make decisions for pricing, for ordering, right? Predicting next week's demand is relatively simple, right? Try predicting 18 months out, right? That gets a little bit more difficult. And all these things are absolutely required to operationalize or put data machine learning algorithms into practice, okay? So, that's the impact of automated decisioning. We don't want to make mistakes. We want good data. We've got a lot of data coming through. And to do this, you have to engage in ruthless automation, right? So if it can be automated, automate it, right? It's simply not going to scale if you're injecting people into the process. I think that you covered that in yours, where you're replacing a human being's judgment with a machine learning model, okay? That's ruthless automation. And you can also apply this to your operational, right? So in the, let's say that you have tens of thousands of machines running, and if one of those machines goes down or a group of those machines go down, it costs you some money, right? Well, I can use predictive analytics to tell me that's going to happen before it does and replace that hardware, okay? So ruthless automation. Machine learning engineer, this is really important today, and this job description is just becoming pseudo-adopted, right? And so anybody with a little bit of intelligence or applied intelligence, right, can download any number of models from the internet, or even better, right? The robots are coming. I can test any number of models, right? Any number of scenarios, and I can do it on the cloud. And I can get a better answer than I can by employing 100 data scientists, right? 9 times out of 10. And if you look at Kaggle, this is how they're doing it lately. The top 2 or 3 entries on a lot of the data science competitions, they're solving with automated learning procedures. They're just letting loose the models in the cloud and letting the cloud tell you, say, these are my top 3, okay? The outlook is cloudy. Use the cloud, as Dat said. You know, don't invest in huge infrastructure, you know, to get these things going. Prove your hypothesis, make mistakes, get your processes down before you start investing in hardware. And the rise of the data science citizen. If you get your data governance right, you get your data management right, you get your data engineering right, and you start teaching people what machine learning is, or what predictive analytics, what prescriptive analytics, or what descriptive analytics are, you can start putting that power into your customer base, right? Notice I said customer instead of user. Right? It's another area that Dat and I agree on. User, to me, is one of the worst things that you can call somebody, because we'll all screw over a user, right? But you won't screw over a customer, right? And so I prefer to sell products to customers, and I love having a BI team that is empowered, and that's not a word I use often, with the right metadata and the right data easily available so that they can do their own thing. I don't want to answer those questions. Right? That's just a drag. If you've got people in the business group that can do this stuff on the business lines, that can do their own BI reporting, and you make the data available to them with the appropriate controls, then productivity will go up. If you do this with your data science teams. So, you know, in Silicon Valley, the biggest war in the data science world is, did you come from Berkeley or Stanford? That's a joke. Hard group. Okay. If you do these other things right, and you bring your data science, your PhDs in, you want to create a culture of data, right? Making decisions based on data, not based on ego, not based on opinion, right? Show me the data. And so what a data scientist should be doing is research, right? The stuff that I can't download, right? Teaching, right? You should be establishing curriculum in your companies, teaching people how to use different models. There's a lot of software products out there. Alteryx is one, right? They claim that they're bringing, you know, data science to the masses. The worst thing that you can do is give a rookie driver a Formula 1 car. Okay, so a data scientist's job should be helping people by teaching them what models to use in what scenarios. And then working on the thorny problems, right? Again, research. What isn't available? Let's advance the state for my company. And the one thing that I've noticed, I've actually been living in Germany for a couple years, but I was working for US companies remotely, and now I work for German companies. This is missing in Germany. This is how Silicon Valley outdoes the majority of the world when it comes to stuff like this. The product manager in Silicon Valley is probably the most important role in any large software company, right? They determine what gets built, right? They're the voice of the customer. They understand the business model, right? It's also one of the most thankless jobs because they have no authority. Nobody works for them, right? And this isn't defined in Scrum. The only thing that's defined in Scrum is the product owner, because that person owns the resources, okay? So if you don't think about product management, what are we building? Why are we building it? What are my personas, right? There's Bob the buyer, there's Oscar in operations, there's Annie in accounting, right? Am I meeting the needs of my personas? Then you're going to sprinkle data science on projects, right? And you're not going to get the return because you're not building products. You're doing the same thing that we did with BI, 10, 15 years ago. The other thing that taking a product approach is accountability is important. And so what I've been a part of in large and small companies is we take product management, project management, product owners, data science, machine learning engineers, data governance, et cetera, BI reporting. We put them in a team with the business, and we say, go generate P&L, right? And if they don't generate P&L, you don't need a machine learning model to figure out what happens next. Any questions? That was pretty quick. I speak fast when I'm nervous.
Thanks, Colin. Last up, is Maria Borna. She's an AI engineer at Zane.io. Welcome. Cheers.
Thank you. Okay. So, yeah, I'm just presenting you the project I'm working on for the Zane company. Here. So Zane just started as a research project in the Oxford University focused on blockchain technology, but we are also focusing on AI and machine learning parts, yeah. So what is our goal in the machine learning part is to let the human interact with the AI, so with the machine learning, and also we include also here blockchain technology. So the big goal of our company is to have an automated and optimize the human-based workflow by integrating the human and using AI. So, and this topic, AI interacting with the human, we are using for the accounting system. So we want to automate the accounting system. So you can imagine the accounting system is quite complex, yeah, and the number of bills one company receives is increasing. Every year it is always increasing. And of course there are only a few people making this accounting and making the booking. So you always have limited resources. It is quite expensive doing this accounting system. And just one example, if you go for a travel to America and you pay everything with your credit card, and at the end you have your bill of your credit card and send it to your company, it will take the accounting 7 days to handle the complete bill of the credit card, yeah? So it takes a lot of time and it's also quite expensive. Now as a company you could do two things. First, you can maybe hire new people, but of course it's expensive. The second thing you can do is one people needs to process more invoices or more bills, yeah? But this is quite difficult if you're not automating the process. So our goal is now to automate this accounting process in order that every person can handle more invoices or bills, and we also ensure quality requirements of each company for the accounting. So of course we have this bill here on the right side, and you want to just scan it and send it to your company, and the accounting of your company can then make the booking into the SAP system. Yeah? So at the end it sounds quite simple. Yeah? So what we want to do as Zane, as a company, is we want to ensure the end-to-end workflow from the scanning process of the bill to the booking into the SAP system. So how we do it? So we are doing it in the following way. So we just learn from the accounting people itself, yeah? So everything the accounting people are doing is tracked by us, and we use machine learning to learn from this, yeah? And as we heard already before, trust is very important. So we make the whole process transparent so that you can really trust, and at the end, everything is controlled by the human, by the accounting people, yeah? And so everything is really transparent and you can really trust this. And at the end, as an accounting person, you're still doing some work because you have the full control and you have to make the decisions if the machine learning part did the right thing or not. And if it didn't, then you have to fix it and report it. And of course, if you have like an automated accounting system, you can also include anomaly detection, meaning if your data is just wrong, if your bill is wrong, or some addresses are not up to date, you can just fix it by this anomaly detection. So how does our automatization process in the accounting looks like? We can split this in 4 different modules. So first of all, we have the recognition module, then the aggregation module, the prediction module, and the decision module. And everything, just saying, is implemented in the SAP system. So the companies can still use SAP. Yeah? This is quite important because I think most of the companies are still using SAP, and our workflow is still integrated here. So let's go into detail for each module. So first of all, we have this recognition module. So imagine you have like your bill, to just scan it with your phone via mobile capture, for example, or you have just a PDF. Then you can perform some OCR, so you can get a digital invoice out of your PDF or paper invoice. And here you can already include a machine learning part. For example, the bills or invoices look different from America and in Germany. So you can already here put some intelligence inside, yeah, that you can learn from. and then you receive the digital invoice. The digital invoice is then here used in this aggregation module, and here we put to every invoice some additional information. For example, the company needs the information with whom you have traveled. Yeah? So this information is put in here, and it's defined by the regulation of each company itself, and then we get the aggregated data. The aggregated data is then split in trainings data and new data. So this data is used for the prediction model, and here we have the machine learning part we are working on. So we have the trainings data, the training data, and this we use for the training and the machine learning. Then from the machine learning we get a model, so we can fit our new data here through the model and get a prediction. So that means if we have a bill or an invoice, we get the booking account, yeah, for the SAP system here as a prediction. You can imagine that this machine learning part looks, it looks first of all quite easy, but it's of course quite complex because you have many hyperparameters in your machine learning system, and every hyperparameter influences the other one. Yeah? So this is quite complex, and at the end you have so many machine learning parts and so many models that you have to check which one is the right one for your case and for every company cases. Yeah? So this you check with your test data, and then you choose the best model. And of course you have here a lot of data science. It's many work sitting here. So the prediction later from your invoice you can take and put some business rule here in it. The business rules are always different and defined by the companies. This can be, for example, if your invoice is above 5,000 euros, then you put it to further review. If it is below 5,000 euros, you can put it directly to the SAP system for booking. And another business rule could be the anomaly detection. If you observe here some anomaly or some data is not up to date, you can also put it to the review. Here in the review block, you have the accounting person sitting. Yeah? The accounting person can now decide if the prediction of the machine learning part was right or not. So here the whole control is always on the human. Yeah? And it's quite important because for many people this machine learning is still some magic, and they don't really trust this. And we really want that the people can trust the machine learning, and this is how we want to solve this problem. So the decision of the prediction, so of our machine learning part, and also of the accounting person here goes then as a feedback for our training, so that we can always improve our accounting system. So how does it look like? So at the end, if I go for a travel, for example, if I have an invoice, then I just scan it with my mobile phone and send this scan to the company. The accounting people in the company, they just see the invoice and also the prediction of the machine learning part, and they can now decide if the decision is right or not. If it is right, you can just say, yes, it's right. Yeah? It's like in the Tinder model. And if it is not right, you can edit everything. You can edit these things, and or maybe you just say, or the accounting person say, no, I'm not the right person to judge, so you can put it to further review. So, and since every decision done by the machine learning part, by the AI, and also by the accounting people is saved in the history by blockchain technology, the accounting manager can always check what happened and why. So if there are any troubles or problem, you can always see the history and check if everything went wrong, everything went fine or not. So as I already said, the accounting people, they need up to 7 days for one bill for a credit card if you go to America. Yeah? So 7 days, it's quite a long time. With our AI and human interaction, you just need 3 days from the scanning to the booking into the SAP system. So you can imagine it saves a lot of time and also a lot of money. Yeah? You save much more money here, and you don't need to hire more people, even more, because accounting is quite expensive. Yeah? And you just have this automatization process, and each person can do even more work or process even more invoices. And of course, since you're much faster with the booking process, you may also get an early payment discount, which also saves a lot of money for a company. So why would you change, or do you need to change to the automated accounting system? So the point is that as I already said, yeah, the accounting people, they have so many work to do, and it's always the same work. And of course, by doing always the same work, you're always doing mistakes, yeah? And we want to do we want to have some high quality accounting system. So here, with our automatization process, we ensure this high quality accounting, and we can also change from these routine tasks to some meaningful tasks. So the accounting people, they just have fun with sliding, if it is right or not, with this Tinder thing. And in addition, they can also, they can also do some other projects, yeah, which is maybe more important for the company and is also more fun for the people itself. And of course, you always see if your data is up to date or not, but because we are using anomaly detection. And I don't know if you have already experience with this, but many companies, they are still using a lot of paper. Yeah, if you go for a travel, you always have to fill this paper, and we want to digitize everything so that at the end we have really no paper using anymore for these accounting people or anymore. So, and at the end it's also an advantage if you go for a travel, then you directly get your money back. You don't have to wait like 2 months or something sometimes until you get your money back. Yeah, you directly get it. So I hope I could convince you that an automated accounting is quite useful, and I hope to talk to you later. Yeah, thanks.
Yeah, that's it for now. Thanks very much, Dat, Maria, Noah, and Colin. Feel free to stay around. There's some beers. We're going to do a competition prize draw. I don't know if anyone or how many of you have actually answered the question. That will be in about 10 minutes. But thanks everyone for coming. Cheers.